This is another chemical equation to balance, but this equation is given to you mostly in words. That's okay though, because you have enough information to convert the words into symbols. The first chemical is propane. You're actually given the chemical formula for that. It's C3H8. Then you're told it reacts with oxygen. You know oxygen is a homonuclear diatomic, so oxygen's chemical formula is O2. In chemistry, we abbreviate the words to make with an arrow. So to make becomes the arrow in the chemical equation. Carbon dioxide, you know how to convert that to a chemical formula. Carbon is C, dioxide means two O's, so carbon dioxide is CO2. And finally, you better know what water is. That's H2O. So we can convert this series of words into a chemical equation. So the chemical equation is C3H8 plus O2 makes CO2 plus H2O. Now we can balance. To balance, we look at each type of atom and make sure there are the same number of those atoms on both the reactant side and the product side. Now the trick here is to work with atoms that appear only once on each side of the chemical equation. Those are the atoms we start with. We'll get to the rest of the atoms later, but our job is easier if we start with the atoms that appear only once on each side of the chemical equation. Look at carbon. Carbon appears only once as a reactant, C3H8, and only once as a product, CO2. So that's where we ought to start. How many carbon atoms are on the reactant side of the equation? The C3 means there are 3 carbon atoms in the molecule. There's no number to the left, so the total number of carbon atoms on the reactant side is 3 times 1, or 3. On the product side, there's only 1 carbon atom in CO2, and there's only 1 molecule of CO2 right now. So we have 1 times 1, or 1 carbon atom on the product side of the equation. So we have to balance the carbon atoms. How do we do that? Well, we play with the numbers that appear to the left of the molecules in the chemical equation. Well, let's rewrite the chemical equation first. Now, I need more carbon atoms on the product side, so let's multiply carbon dioxide by a number to make more carbon atoms on the product side. I need 3 carbon atoms, so it makes sense to multiply CO2 by 3. Now if we look at the carbon atoms, the reactant side of the equation hasn't changed. I still have 3 times 1, or 3 atoms of carbon on the reactant side of the equation. The product side of the equation, I still have only 1 carbon atom per CO2, but now I have 3 CO2 molecules. So 1 times 3 is 3, so I have 3 carbon atoms on the product side of the equation now, so carbon is now balanced. Alright, let's move on to another atom. Now remember, we want to try and restrict ourselves to atoms that appear only once on each side of the equation. I can do that if I work with hydrogen atoms. Notice that hydrogen atoms appear only once on the reactant side of the equation in C3H8, and only once on the product side of the equation in H2O. So let's balance the hydrogen atoms. On the reactant side, I have 8 hydrogen atoms in a molecule of C3H8, only 1 molecule of C3H8. So in the end, I have 8 times 1, or 8 hydrogen atoms on the reactant side of the equation. On the product side of the equation, I have 2 hydrogen atoms in a molecule of water, and only 1 molecule of water, so I have 2 times 1, or 2 hydrogen atoms on the product side of the equation. So the hydrogen atoms aren't balanced. We're going to have to balance them. So let's rewrite the equation. Now, I want to play with the numbers again, but I have to be careful. I don't want to alter the number in front of C3H8 or the number in front of CO2. I've already used those to balance carbons. If I were to change either of those numbers, the carbon balance would be off. So I can't touch those numbers. However, I can balance the hydrogen atoms if I just put a number in front of H2O. I need 8 hydrogen atoms on the product side of the equation. I can get that if I put a 4 in front of H2O. Now look what we have. On the reactant side of the equation, nothing's changed for the hydrogen atoms. I still have 8 hydrogen atoms in C3H8, 1 C3H8 molecule, so a total of 8 hydrogen atoms. On the product side, I now have 2 hydrogen atoms per water, but I have 4 water molecules, so I have a total of 8 hydrogen atoms on the product side, and now the hydrogen atoms are balanced. Well, there's only one more atom to consider. Unfortunately, it appears twice on the product side of the equation, but we don't have any choice. We've got to deal with it now, so let's deal with it. On the reactant side of the equation, there are 2 oxygen atoms. O2 means there are 2 oxygen atoms in the molecule. There's only one O2 molecule, so 2 times 1 is 2 oxygen atoms. On the product side, I've got oxygen appearing twice. First, it appears in CO2. O2 means there are 2 atoms per molecule of CO2. I've got 3 molecules of CO2, so I have a total of 2 times 3, or 6 atoms of oxygen coming from CO2. But I'm not done, because there's also oxygen in H2O. H2O has 1 atom of oxygen per molecule, but I have 4 molecules. So I have a total of 1 times 4, or 4 oxygen atoms coming from water. The total number of oxygen atoms is the sum, so I have a total of 10 oxygen atoms on the product side of the equation. So obviously, I have to balance the oxygen atoms. Okay, well, let's rewrite the equation and see what we've got. We don't want to change C3H8 or CO2 because that'll mess up the carbon balance. And we don't want to change C3H8 or H2O because that'll mess up the hydrogen balance. So I've really only got one place I can play, and that's on the O2 on the reactant side of the equation. That's all I need, though. I need 10 oxygen atoms on the reactant side of the equation. I can get that by multiplying O2 by 5. When I do that, and then I look at the number of oxygen atoms on the reactant side of the equation, I have 2 times 5, or 10 oxygen atoms on the reactant side of the equation. The product side hasn't changed. I have 2 times 3, or 6 oxygen atoms coming from the CO2. I have 1 times 4, or 4 oxygen atoms coming from the water. That's a total of 10 oxygen atoms. So my oxygen atoms now balance. That means the entire reaction is balanced because every kind of atom is balanced. So the final reaction that's balanced is C3H8 plus 5O2 makes 3 CO2 and 4 H2O.